Okay, in the last video, we talked about the parent function for absolute value, and we talked about vertical and horizontal translations. And now we're going to keep moving forward. Here you'll notice we also have a number being multiplied times the absolute value, and we're going to look at what that does. So I went ahead and plugged in our x values into the function that we were given, and then we just compute to find our y values. So this gives us a -1 inside. The absolute value of -1 is 1 times 2 is 2. And we just keep calculating for each one of those. And I'm going to plug those in down here so that we have our ordered pairs written together, and then we can plot those points. So -2, +2, 1, 0, 0, 2, 1, 4, and 2, 6. Now, since we know these absolute value graphs are going to be symmetrical, we can go ahead and plot the mirrored points for these on the other side. I didn't quite get those points on the right spots, but they're close. Now let's compare this graph to the parent function. The parent function is right here. And we'll notice that a couple of things have changed. One is we see that there's been a horizontal translation. That's what that +1 did. It moved us to the left. But we also notice that our graph is narrower than the original graph. And we call that a vertical stretch. And then we always use what the factor was that was multiplied times the absolute value. So we say by a factor of 2. So this one is a horizontal translation and it's a vertical stretch. That's what this number out in front does, is it's going to change our shape. It's either going to make it a vertical stretch or it's going to make it a vertical shrink. Now let's kind of put all these together. All of our functions have been in this form. And so what we want to do is when we look at the equation, we want to be able to identify which number is A, which number is H, and which number is K for each one. So let's start with this first one. F of x equals the absolute value of x minus 2 minus 5. We notice that we don't see a number out here for A. That means A is 1. That tells us it's going to be the same shape as the parent function. Then it's always x minus h. Since this is x minus 2, h must be +2. And then plus k, and this says minus 5, so k must be -5. On this next one, we see the number out in front is a 1/2, so a is 1/2. That's going to make it a vertical shrink. It's going to make it wider, where when it was 2, it made it narrower. H, well, this is x minus 3, and since it's minus h, that must be 3. And k plus k, so that's a +4. On this next one, A again is 1. We don't see a number out there. And then here we see a +1. Since it's minus h, in order to get a +1, it must have been x minus a -1, because that's what would give us an x plus 1. So h is -1 and k is -2. For our last one, A is -3. H is, well, since we have a plus again, that means it must have been x minus a -4. So h is -4, and we don't have a number out here, so k must have been 0. The last thing I want to do here is help you see what all of those variables do. What do the a, h, and k do? And we've graphed a few, so we've seen it, but I think it works a little better if we use this graph right here. This is from a website called Desmos.com. It's a great website for graphing if you want to use it. And what it allows us to do here is I put in our function with a, h, and k, and I created little sliders so we can change the value of h and k and a to be whatever we want. So what I want to look at first is what happens when we increase the value of k. Well, when k is 5.8, it's been moved up 5.8. When k is -5.3, it's been moved down 5.3. So it seems that k makes our graph translate vertically. It doesn't change its shape in any way, it just changes where that vertex is. And when k is positive, it moves it up, and when k is negative, it moves us down. So when we look back at this page, k is our vertical movement. It moves us up and down. It moves us up when k is positive and down when k is negative. Now, let's look at h. Now remember, h has that minus in front of it. So that changes things a little bit for us. When h is positive, it's 3.6. That moves us to the right. And when h is negative, it moves us to the left. So that kind of makes sense. Positive to the right and negative to the left. However, when we're looking at it in the equation, in order for h to be negative, our equation has to show it to be plus 1. So when we see a plus 1 in the equation, h is actually a negative 1, and so it's going to move us to the left. When it shows up as a negative, that means h is actually positive, so that moves us to the right. I always say h is the opposite of what you think it is, and that's because of that minus sign right there in the middle. The last piece is our a, and a is the one that changes the shape. When a is larger than 1, it makes it a vertical stretch. When a is a proper fraction between 0 and 1, it's going to make it a vertical shrink. So that means it makes it wider. You'll notice when a is negative, that gives our graph a reflection. So when a is positive, it opens up, and when a is negative, it opens down. And then on your homework, you're going to explore with all of this. They're going to have you graph a lot of functions, and they're always going to say compare it to the parent function. So it's a good idea to graph it, graph your actual function, and then always graph the parent function so you can see what the relationship is between the two.